Solving a quadratic by factorising? Ugh, that's for babies. Solving a quadratic from drawing the graph and seeing where it crosses the x-axis? Babies. Solving a quadratic through the quadratic formula? That's a real agent move. And when you evolve to a next level of math skill, you'll be able to just plug random numbers in until you get zeros. So, beside the jokes, factorising is good, drawing a graph is good, quadratic formula is also good, plugging numbers in until you get zero, terrible. Quadratic formula is on the right, and that's what we're going to look at today. I'll explain that in more details, but first I've got a nice story from my childhood including the quadratic formula. So when I was a little baby, before I could speak, I was there and I was going da 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 da, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's a true story, they were my first words. And when you know the quadratic formula, no one will ever hack into your Wi-Fi password router ever again, because they just won't know the password. Alright, stop being daft now. Real lesson. So, this is the quadratic formula. You'll have seen this before, because I know it's been in some of our starters, and it's always posed the question of what is that? It is another way of solving quadratics. So, when you can't always factorise everything, or you can't factorise everything with whole numbers. So when we get some more difficult quadratics, this is always a nice little backup method, because it works for every single one. Any single quadratic you get, as long as you make it equal to 0, plug your numbers into this formula, it will work for every single one. So what I mean by my letters here is a is whatever the number is before x squared, and that links up to the a here and the a there. The b links up to what is here, so that sign comes before it, so if we've got minus something x, it'll be a minus number. Comes here, and then this c there just links up to this guy over there. And we've got a weird plus or minus in the middle, which is a sign you might not have seen too much before. That just means we want to do it once with a plus sign there, and then another time with a negative sign there. And you know from quadratics we generally get two solutions, not all the time, but we generally get two solutions. So it makes sense that through this quadratic formula we get two solutions as well. I'm going to go into some examples. So this one, I'll draw it out a little bit bigger. This is already equal to 0. So we straight away can take our numbers and plug it into our quadratic formula. So the square root of b squared minus 4ac all over 2a. This is something you're expected to learn as well. So maybe screenshot one of them memes and put it as your background on your phone for a few weeks, and hopefully you'll learn it. It's one of them things you surprisingly can just roll off your tongue after saying it a few times. So in this case, a is equal to 1, b is equal to 5, positive 5. Remember, we have a bit of a ghost one here before. And c is equal to 1. So I want to do it once with the plus sign. Let's go ahead and do it with the plus sign. So x equals to minus b, which is minus 5, plus the square root of b squared, which is 5 squared, minus 4 lots times by 1 times by 1. That's times by a and c. We know 4 times by 1 will just be 4, but we'll sort that out in the next line. And then 2 times by a, that's 2 times by 1. So let's tidy this up a little bit. We've got minus 5 plus the square root of 5 squared, which is 25, minus 4, all divided by 2. And this is going to be minus 5 plus the square root of 21, all over 2. From here, you'll generally get horrible answers with the quadratic formula. That's the whole point. It's there for when it's too hard to draw the graph and see exactly where it crosses, and it's there for when it's too hard to factorise. So you'll know to use the quadratic formula. I'm going to do an exam question at the end, but it'll say give your answer to so many decimal places. You know, okay, I definitely can't factorise that then, because when you factorise you always get whole numbers. So I'm going to type that into my calculator. -5, or my fraction button, then -5 plus square root of 21, go to the bottom of my fraction, divide by 2, and this gets me minus 0.2087. And then I'm going to do it with my minus sign. The numbers actually don't change, do they? Because all we're doing is changing this symbol. So it is actually just -5 minus the square root of 21 all over 2. So actually on your calculator, if you've got your scientific one, you can actually just press left on your calculator quite a few times, delete that plus sign, replace it with a minus, and we get minus 4.79, so on. So our two answers are x equals minus 4.79 and x equals minus 0.21, and I've done that to 2 decimal places. So that's definitely nothing you could factorise, and it's not something you'd spot on a graph accurately, is it? So example number 2, this is where it comes in really handy, because these are harder to factorise when we've got a number that isn't 1 before the x squared, and we haven't looked at how to factorise them yet. So if you see something like this, the quadratic formula is kind of a way to solve it. So I'll draw my quadratic formula out again. The more times you write this down is better. So every time you do a question, write it out, because that's the way you're going to learn it. So a equals to 2. B equals to minus 1. Not just 1, because it's x, it's minus x. And c equals to minus 9. So I'm going to do my substitution in here. So minus 1. So minus 1. That's actually going to be positive 1, isn't it? So I'm going to leave it like that for now. And I'm going to leave the positive negative sign in there, because I know I can just do it once in my calculator with a plus, once with a negative, and I'll do that at the end. So then I need to do negative 1 squared. Remember, you need that negative 1 in a bracket if you're doing that in your part in your calculator. Minus 4 lots of a, which is 2, times by c. So that's 4 times 2 times minus 9. And then divided by 2a, so that's 2 times 2. So we said this minus 1 is just 1, plus or minus 1 squared, well that's 1, minus 1 times minus 1 is 1, 4 times 2 is 8, times by minus 9 is going to be minus 72, but we're subtracting that, so it's going to be subtract minus 72, which is actually going to just be a 1 plus 72 if I kind of skip that step ahead. You can just put all of this in your calculator, by the way, if you're very, very careful with your brackets, which we've done a lot of practice on, so we should be. Divided by 4. Divided by 4. So this is 1 plus or minus the square root of 73 all over 4. So I'm going to do it with my plus sign, so that is going to be x equals to 1 plus the square root of 73 over 4, and I'm going to do that in my calculator. 1 plus the square root of 73 over 4. That gets me 2.3860 and so on. And then I'm going to do it with my minus sign. And that's x equals to 1 subtract the square root of 73 over 4. So just scroll back in your calculate button with the left key, put a minus there, and we get minus 1.886, so on. So my two answers, again I'm going to do this to 2 decimal places, is 2.39 and minus 1.89. Always state what you're rounding to as well, so 2 decimal places. Okay, got this example, then an exam question. We need to rearrange this to make it equal 0, so it has to equal 0 to use the quadratic formula. So before I do anything, I just need to adjust this a little bit to be x squared plus 7x minus 20 equals 0. Then I can say a equals to 1 from here. That's a bit of a ghost 1, isn't it? B equals to 7 and C equals to minus 20. So into my quadratic formula, which is, say it with me, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. It's beautiful. So, substituting these values in down here, we're going to have x equals to minus b, which is minus 7, plus or minus the square root of 7 squared, minus 4 lots of a, which is 1, lots of c, which is minus 20, all over 2a, which is 2 lots of 1. So you can just pop all this in your calculator at once, what you can do there. Generally, I'd probably only just do the square root stuff in the stuff that's underneath here, so that b squared minus 4ac could be useful to do in your calculator. The rest of it is quite easy to just keep writing down on your paper. You don't want to do too much in your calculator at once, because if you make one mistake, it's really hard to spot if you've done that. Because people like to blindly believe their calculator. So 7 squared is 49. Minus 4 times 1 is what? 4 times by minus 20 is minus 80. All over 2 times 1 is 2. So we need to do this 49 subtract minus 80. When we've got two subtracts like this, it just turns into a plus. So we've got minus 7 square root of 49 plus 80 over 2. 49 plus 80 is 129. So then again, I'm going to go just a little bit. I'm going to go here, and I'm going to do it with my plus sign. So x equals to minus 7 plus the square root of 129 over 2. So I'm going to do that. Minus 7 plus square root of 129 over 2. Which gives me 2.1789. And then when I do it with my... Ooh, hello. When I do it with my minus, scroll back on my calculator, save me typing it all again, and I get minus 9.1789, so on. So I can say my final two answers. I'm going to round it to 2 decimal places again. 2.18 and minus 9.18. And always say what you have rounded to 2 decimal places. Okay, this is an exam question here, so this is how you're commonly going to see it. It's going to blend in with our forming and solving equations skills. And it's quite a hard thing, but they always love to give you 5-6 marks for it. So practicing it now, all this solving quadratics is so important, because they just give you massive marks. For doing questions, if you understand it, aren't too long, and they aren't too troublesome compared to some of the other questions there. So the diagram shows a rectangle with the area 9 centimeters squared. So we know when we find the area of this, it's going to equal 9. Set up and solve an equation to work out the value of x. Give your answer to 3 significant figures. That there gives me a clue that I'm probably going to be using the quadratic formula, because if I factorised, I'd get a whole number. If I could draw the graph, I'd get probably a whole number or a half or a nice fraction. Because they wanted it's 3 significant figures, that means I'm going to get a horrible number in my calculator, and that's generally what the quadratic formula gives us, and it's what it's good for. So the area of the rectangle equals 9. We've been told that in the first line. Well, we can also find the area of the rectangle with algebra. We do length times width, don't we? So we want to do x times by 2x minus 1. And when we expand that, we'll get 2x squared minus x. Yeah, just expanding that. Well, they're both the area, so they must be equal to each other. So I can say 2x squared minus x equals to 9. I want to rearrange to make this equal to 0. 2x squared minus x minus 9 equals to 0. I can use my quadratic formula here now. So my quadratic formula is so a equals to 2, b equals to minus 1, and c equals to minus 9. I'm not going to write out the whole thing. I'll write out kind of the large chunks of it. So, actually, no, I'm not going to do the smallest steps, just for my space. So minus b would be minus minus 1, which is just positive 1, equals b squared, minus 1 squared is 1, and minus 4ac, well that's 4 times 2 times minus 9, that would be minus 72, and if we're subtracting minus 72, so what I've done there is I've done this, in there. That's kind of what I've done. So there's a minus sign there. Minus 72 gives me the positive 72. And then 2a, which is 2 times 2, which is 4. So that equals to 1 plus or minus the square root of 73 over 4. Is that very similar to one we've had before? Seems like it. So then if I do it with the plus sign, so 1 plus the square root of 73 over 4, that gets me 2.3860 so on, and it also gets me, when I do it with the minus sign in there, that gets me minus 1.8860 so on. We've definitely done this. I remember these solutions. That's quite cool. I did not plan that. And then 3 significant figures. So final answer down here, x is going to be equal to, well, 1, 2, 3, draw a line. This makes us round up. So 2.39, 1, 2, 3, draw a line. This makes us round up. So x equals to minus 1.89 are my 2 final answers for this, and that is to 3 significant figures. And if you put 2.39 into these x values here, you would get a value of 9, but we need to stop and think about, well, is this a sensible answer, this second one? Is minus 1.89 a sensible answer? If we put it into here, we'd have a length of minus 1.89. So actually, this is a very common thing with these questions. You get that final mark for thinking about your answers and checking if they make sense. This answer here is not possible because we can't have a negative length. This is a very common thing with these questions, because solving a quadratic gives you 2 answers, but it doesn't always, the answers don't always make sense in real life, because sometimes maths and real life, you've got to use a little bit of brain power to link them together. Maths does a bit too much work than we need sometimes, and in this case it does it. So from your 2 answers, I've crossed out that one and I said, well, you have to have a line of reasoning as well. You can't just leave it out. You've got to say, well, it's not possible we can't have a negative length, because we can't have a length of minus 1.89 centimetres. That just doesn't make any sense at all. But we can have a length of 2.39 centimetres, and that works. So that's all I've got for you today. Thank you for listening.